Welcome to Algebra, Solving Systems of Equations Part 4, Advanced Elimination. In this lesson, we expand the study of elimination started in the last lesson, looking at more complex situations that can still be handled using this process. In the last lesson, we examined systems of equations in standard form with identical or opposite x or y terms, like this one, where the x terms match and we use the elimination process to solve for y, then solve for x. Or this one, where the y terms are opposite, and we again use the elimination process to solve for x, then solve for y. Sometimes, in a system of equations like this one, there are no terms that match exactly, or are exact opposites. None of the x or y coefficients match. None are exact opposites. There is no way to eliminate either x or y terms as the equations are now. However, the elimination process is still possible. You just have to fudge a bit. Notice the x term coefficients, 4 in the first equation and 2 in the second one. They don't match, they aren't opposites, but they do relate in an easy way. If you multiply 2, the coefficient of x, by negative 2, it becomes negative 4, the opposite of 4. And when combined, the x term will have a coefficient of 0 and drop out of the equation. However, in algebra, we treat all parts of an equation the same way, so we must multiply all the second equation terms by negative 2, creating a new equation, negative 4x minus 10y equals negative 2, but still equivalent to the original equation 2x plus 5y equals 1. It is still the same line if we graph it, as you can see in the example in Desmos. Once this transformation takes place, then the equations can be combined, the x terms drop out, we solve for y to get 1, we substitute back into the original equation, and solve for x to get negative 2. And you can see the proof in the graph that the solution point, negative 2, 1, is correct. Here is another example. Take a moment and strategize. What needs to happen to make this system solvable using the elimination process? Pause the video if you need to. If you noticed, the y terms have coefficients 6 and 2, which easily relate. The 2 can be multiplied by negative 3. The new equation is negative 12x minus 6y equals negative 36. Combined with the other equation creates a new equation without the y term, which we can solve for x, which is 6. Substituting that value for x and solving for y results in the value negative 6. The solution point being 6, negative 6, as you can see confirmed by the graph. Let's look at this system of equations. Pause the video if you need to. In looking at the 4 coefficients of x and y, none of them match. None are opposites. And so we need to consider how we might manipulate one of the equations so that terms will drop out and we can work the process. Look carefully at the x terms. Do they relate? If you thought we can multiply the 2 in the first equation by negative 3 to make negative 6, that creates the opposite of 6 of the second equation x term, and then they will drop out. This is the correct approach. Working through the process yields an equation where the x terms are eliminated and the solution for y is 8. Substituting 8 in for y in the original equation gives us the value negative 9 for x, the solution being the point negative 9, 8, shown to be correct in the graph. But wait! What about the y coefficients? Are those related? Can we change one of those to manipulate the equation to enable the elimination process? The answer is yes, we can. We can multiply the second equation by negative 2, which creates opposite y terms, which will then drop out. And we can proceed with the solution negative 9 for x and 8 for y, the same solution as before. When you can do either approach, They both work correctly. Here is a sample test question we can solve using elimination. Check it out. Pause the video if you need to. This is another situation where two different approaches will work. We can either work by eliminating the x terms, which relate, or the y terms, which also relate. Either way will work. Let's do the x terms. We multiply the first equation by 2, which will cause the x terms to have opposite coefficients -6 and 6, which will drop out and lead to the solution for y, which is 3. Substituting back into the original equation gives us the value of x, which is -2, which matches choice B. Here's another test question you might see on STAR. Pause the video and work it out. This time we'll eliminate the y terms, multiplying the first equation by 2 to get opposite y coefficients 2 and -2. Those drop out when the equations are combined, leaving 12 as the solution for x. Plugging that value back into the original equation gives us 16 for y, revealing the point 12, 16 as the solution, matching choice A.